Hello friends, welcome again. In this session, I will talk about lists and tuples in Python. So let's get started. So as you would be knowing, there are four main data structures in Python, right? And we also call this data structures as collection type because they hold more than one value, right? Collection types, and these are, if you can think of, list, tuple, we say tuple or tuple, whatever you feel fine, sets, and dictionary. These are the four important data structures and collection types in Python. Why do we say collection type? Because these hold more than one value. Your integer hold one value, string hold one value, but these hold more than one value, a list of values, right? So that's why these are called collection data types. It collects some values inside it. Now, as you know, list is enclosed in this square brackets. For example, a list of 1, 2, 3, 4 numbers. Tuple is enclosed inside this brackets, 1, 2, 3, 4, and a set is enclosed in this curly braces, and this is like 1, 2, 3, 4. And a dictionary is something like a key value collection, right? Key value collection. For example, let's say I'm talking about what's the brand. I'm talking about a phone. Let's say brand is iPhone, right? So the key is brand and value is iPhone, right? And let's say I talk about the model number, model, uh, and let's say model number is 15, that's iPhone 15. And let's say another key is price. Price is, let's say, I do not know, 69,999 might be, right? 69,999. I hope this is clear, right? Now, these are the four important data structures that you should know in Python. And if you want to go in data field, like a data engineer, data analyst, data scientist, talking about these collections is super important, right? So in this session, I would talk about list and to some extent tuples. Now, all of these data structures, whichever I have mentioned, can be categorized into two categories. One is, some of them are sequence types. Sequence types are the ones where sequence is important or the order is important. For example, in list, right? The ordering is important because I can access saying, can you give me index number 1? And this would be this because it starts from index 0. Index 0, 1, 2, and 3. Same is the case with tuple, that we have index 0, 1, 2, and 3. But in case of a set and in case of a dictionary, the order is not important. A set, whatever I have written, is equivalent to 4, 2, 1, 3. Right? This is equivalent to, I mean, both of these are equivalent, if you ask me. Because ordering is not important, and you cannot say that get me the second index. Index is not a thing here, right? Order is not important. That's why your set is not a sequence type. It is not a sequence type. And same goes with dictionary. Whether I have this key before or this key before does not matter. So the sequence does not matter here also, generally, right? So list and tuple, the sequence matters. That's why these are called sequence types. List and tuple, right? Even when you talk about your string was a sequence type because string is a sequence of characters. So sequence matters of the characters, right? Now, another way to think about this is my data type or data structure mutable or immutable? Mutable versus immutable. By the way, I'll stop here and ask you, if you have not subscribed to my channel, do subscribe now because I'm going coming up with a lot of interesting stuff and you would truly enjoy my session. So in case if you feel my content is worth it, do subscribe to my channel, do like the video, do comment on it, and that will be a good enough motivation for me. Yeah. So I was talking about mutable versus immutable. Mutable means the value can be changed. Immutable means the value cannot be changed. For example, when you talk about your string, you cannot change the value. You cannot change the value. So it is immutable, right? When you talk about list, it is mutable. You can change the value. I'll show that in this session. A tuple. The main difference between a list and a tuple is list is mutable. You can change the value, right? You can alter it, but tuple is immutable, right? So when you talk about your big data world or data world, you really want to get data structures which cannot be mutated generally, right? So tuple is very, very widely used, right? Set is again, you can mutate it, mutable, and your dictionary is also mutable. Anyways, our main concentration right now is on list and tuple. So the main difference between list and tuple, of course, the way we define it, it is inside this brackets, right? And these kind of brackets come for tuple, right? These are square brackets and this is a normal bracket. Okay. So let's proceed. So you understood about mutability and immutability. We will see that practically. Okay. So let's get started now with the practicals. Enough of theory. So in other languages, you would have read about arrays, right? In Java, in C, right? So list is almost same like an array. But one thing is that when you talk about arrays in Java or C language, you talk about arrays of a certain type like integer, string, like that. But here list can hold values of different types, right? It can hold values of different types. For example, I can have a orders list. This can be your orders list. This can be your orders list. You see, this is an integer, this is a string, right? This is again an integer, and this is again a string, right? So let me go to my uh, PyCharm, and here I will define this. I will say order equal to, instead of orders, I will say order equal to this. Let's say this is one particular order which I have got from a text file, like, or let's say orders does not matter. Now what I would do is, I can print it, print this orders. Let me run Control R and it will show this. No big deal. Okay. Now let me try to show you, or if I hover on it, it will say this is a list. You can see list, right? You can just have a look that it's saying, and this has some integer type, some string types. That's what it is saying, right? Let me also print the type of it. How do you print the type? I can say type orders, and it should print the same thing, that this is a list. Okay, fine. So we have created our first list right now. Now what we will see is, if you want to create a tuple for this, you just have to change this, right? You just have to change this, right? And if I hover here, it will say it's a tuple, right? You can see this, it says it's a tuple. You can see this, right? And tuple of integer, string, integer, and string. That's what it says. Now if I print the type, you can say it's a tuple. Control R, and it's a tuple. Very minute syntax difference here, but the difference lies in the fact that your list is mutable and tuple is immutable. I'll write it here. List is mutable and tuple is immutable. Very, very important, right? Okay, now let's proceed with this. Let me try to create a list again quickly. I want to show you the list. Now, what if I want to get, let's say, the element at the second index, 0, 1, and 2? Right? I want to get the customer ID. This is On the third column, I have the customer ID. I want to get that. How will I get it? I can say orders of 2, and I am getting this as the customer ID because it is indexed. That means it's a sequence, right? Whenever the ordering of it matters, then indexing will work, right? Then indexing will work. So with the index, I am able to retrieve this value. Just have a look at it. Now, what if I say orders of 5? Actually, we have indexed till 0, 1, 2, and 3. So it's not available. So it will throw an error saying list index out of range. List index out of range. I hope this is clear. Now I will show you how to mutate the list. Mutating the list. So let's say I'll say here uh, orders of 0, 1, 2, and 3. I want to change the order status. Instead of closed, I want to make it complete. Right? Now, if I say orders, let's see, you see this is complete. That means the same list which we were dealing with, we are able to change one of the element. And this is what I am calling as mutability. We can mutate it, right? I hope this makes sense to you. We are able to mutate the list. Now, talking about tuple here, if I would just change these brackets like this to make it a tuple, then do you feel it will work? No, this won't. This won't for sure. It says tuple object does not support item assignment. That means we cannot mutate a tuple. Tuple is immutable. This should give you a clear idea about it, I believe. I'll again make it back to a list. I hope we are good. Now, you understand that in tuple you can access it, you can play around with the data, but you cannot change it. But in list, you can access it, plus you can make modifications. Now, let me add the element at the end of the list. If I want to add something at the end of this list, let's say I want to add the order amount. I want to add the order amount. Then what I will say, orders dot append. Let's say order amount was 100, and I can say print orders. You can see 100 is added at the end. So whenever we append, it's always added at the end, right? It's always added at the end. Of course, for append is available for your list, but for your tuple, it won't be available. It won't be available for your tuple. So it's pretty straightforward. For example, I will say orders list, and let me create a orders tuple here. Orders tuple, and I will just change these brackets, right? So for example, I have said orders list dot append, and I printed orders list, right? So this was working anyways. Now what if I make it to let's say orders tuple? Append itself is not there when you just say like this, right? Append itself is not there, but when we say orders list, automatically you will find append. You can see this, right? So that's a clear cut indication. Let me make this as orders and this as orders tuple. That should be fine, right? I hope this is clear. So what I made orders 3, or orders dot append 100 and orders. Okay, so this is clear that append works for list but not for tuple. Now, same way, what if I do not want to add something at the end? I have a requirement that this order amount I should be adding as a second column. second column I should be adding. Then what I should do? I can basically say insert, and I will define it what index I want to add. If I want to add as a second column, then it's my index 1. On index 1 I want to add 100, right? I'll say control R, and you can see it's added as the second column, that is index 1, right? Very simple things, but you should know, right? Insert won't work for your tuple. Insert won't work for your tuple. Okay, so we have added the element as at the specific index. We added the element at the end by using append. Now, apart from this, we can find the length of this. How do we find the length? We can say length of orders. This will tell how many elements are present in this list. So we can print this. We can print this. 4. Total 4 elements are present, and of course there are 4 elements. Will this length function work for your tuple? Yes, because we are not manipulating it, right? It's just reading and calculating something. So definitely for your orders tuple, also this will work. There is no problem. It will work. So I am trying to build that thought process that you yourself understand what will work for a tuple and what will work for a list, right? Okay. Now, ideally, there are functions like your just like we have calculated the length. We can calculate min, we can calculate max. All of this will work for both your list and tuple. But now, if I try to say min here, will this work? Will this work? Min. Ideally not, because how can we compare an integer with a string? If all of them are integers, we could have done that, right? It will not be able to compare a string with a integer. Not supported, like less than not supported between instances of str and int. Very, very proper thing, right? You yourself can understand. I hope this is clear. For example, if I define orders new equal to 1, 2, 6, 8, 5, right? It will make sense here to find the min. If I say orders new, it will work, right? Same way you can define a max here. I hope we are clear with this. Okay. So you understood about min, max, length. There are a lot of functions. You do not have to worry too much. You can check out the documentation. Now there is one more function which is important, which is pop, right? Pop removes the last element from the list, right? So what I will do is I will say orders dot pop, right? Takes the last element out, and I can say print orders. So what do you expect? It will print one, this date, and this customer ID. It won't print the order status because that's gone. So you can see this. Pop removes the last element. Now, ideally, when you call this pop, it even gives you or it returns the last element. So if you print this also, if you print, what will it print? So it removes, but it will print you for you also, right? So it will show closed. So you see this. So ideally pop, whenever you call this function, it removes the last element and it returns the same. That's why when we are printing, we are able to see this, right? How about for tuple? Will it work? Ideally, it's changing the list in place. Same list it's changing. It's not new list that it is generating. So of course, this won't work for a tuple, but just for your clarification, I'll quickly show you that, right? I can show you that it won't work. Tuple object has no attribute pop because it's not there. It's not there. I hope we are good here. Right? So you understood about what is pop, and sometimes it's necessary for you to remove the last column, let's say. Right? So it will help you there. Now, In other languages you might have read about for loop. So I want to give you some idea around that too, right? I want to give you some idea about for loop. So let's say I have these elements and I want to print each element. I know this is at index 0, this is at index 1, this is at 2, this is at 3. But I cannot say that okay, print orders of 0, print orders of 1. I have to write 4 times then this. Right? What if hundreds of elements are there? Then it's too much of manual work. Rather, I would create a for loop. How a for loop works? For right for x in orders, for x in orders, that means how it works is that this will automatically have a loop, and first time the value of x will be 1, next time it will be this, next time it will be this, and next time it will be this for x in orders colon, right? And now I say what I want to do. I say print x, print x, right? If I try printing this, you can see I am printing all of the elements. But I have not written too much of code that I am printing this manually, this manually, this manually, like that, right? So that's the beauty. I hope this is clear. Just have a look at it, right? Okay. Now, what if I want to print the data type of each element inside this? I can just wrap it inside a type, and this should then print me the types of each element. You can see first one is integer, second is string, third is integer, fourth is string. That's correct. That's correct, right? Okay. Now, I will comment this line for now. I'll comment this line and let me define. I want to have numbers from 1 to 10. So I can define a range like this. Range 1 to 10. If I say 10, 10 is not included. So I will tell 11. That will mean from 1 to 10 all the numbers. Right? And I will capture it inside numbers equal to range 1 to 11. Right? Now what I will do is I want to find, my goal is to find the sum of first 10 numbers 1 to 10. Then what I can do for x in numbers, for x in numbers, I will define something like sum equal to 0 here, sum equal to 0. For x in numbers, sum equal to sum plus x, right? Initially sum was initialized with 0 and every time I am looping from 1, 2, 3, 4 and I am summing this. And I can now say print sum. What would be the sum of first 10 numbers? It is 55. And if I say Control R, that will show 55 to me. I hope this is clear. Just have a look. Right? Now what I would want is, instead of me defining the range here, let me take it from the input. I would say, okay, give the starting range, give the ending range, and we will calculate the sum in between that. So I'll say range start equal to input starting range, right? And whatever I will capture, that will be a string, so I can wrap it inside an integer, isn't it? Okay, perfect. Now range end equal to int. Again I have wrapped it inside an integer. I will take the input and I will say range ending. Okay, fine. Now sum equal to 0, and then for x in numbers, right? So what do we have to say here? So I can say numbers equal to numbers equal to, and then I will define a range. Range is from which to which, whatever I have taken, right? Range start comma range end. But let's say if a user define 10, then of course that person means that I want sum till 10, right? So that should be included. But as per this, it is not. So I will say plus 1. Plus 1. I hope this is clear. Now, if I run this, starting range, let's say 1, ending or range ending, let's say 100. I want to find the sum of first 100 numbers, and that is 5050. You can calculate, right? So that's an interesting thing that we have made. I hope this would make sense, right? Okay. Same way you can play around with a lot of other things, but that should give you an idea about how a for loop works. Now, let me remove all of this and uh, let me have this orders, and what I would do now is, let me say order amounts equal to, and let me let me put some order amounts. Let's say we are getting from a text file some order amount, let's say 100, 200, and somewhere the value is also not there, let's say none, and somewhere it is invalid. Let's say string is coming which is invalid. Ideally it should be integer, but let's say string is coming. Somewhere it's coming integer, somewhere it's coming a float, all of that. Like this, some random values are coming, but ideally it should have been an integer, but data is not clean. Let's say somewhere the value is missing, none shows the absence of a value. Somewhere it's coming like a random string value, right? But my goal is, I want to find the sum of all the proper integers or decimals. I want to ignore all the others. For example, here I want to ignore none, invalid, because I know I cannot do arithmetic operations on this. How do I approach this? So I can say sum equal to 0, sum equal to 0, right? Because working in a data world, you can expect unclean data, right? And you have to deal with it. So let's say you are getting this, and you say sum equal to 0 for x in order amounts. And now what you can say, you can use a if statement. Type of x if type of x, right, this x, initially x will be 100. If I say type of x, that will be integer. If this equal to integer, or type of x equal to float, right? That means these are integers, this is integer, this is float. I want to ignore all the others. So if it is integer or a float, then you participate in the sum. You participate in the sum, right? Else what you do, you skip it. And how do you skip? You say continue. When you say continue, then it's not participated. That means whenever it sees continue, it goes again back to the for loop, right? So for example, when we say 100, initially sum plus 100 will make it 100. Next time when 200 comes, then we will get 300 totally, and then we get none. The type won't match, so it will come in the else part and it will continue. Then it will get invalid, right? Again the type, it won't match, so it will come here, it will continue, right? It will go to the next value, which is 300. So 300 plus 300 will become 600, and same way 600 plus 400.5 will become 1000.5. And now I can print it. I can say print sum, and you can see this is the output. So you can see we have dealt with a messy list which is not clean, and we are able to use the conditional statements in order to make it work, right? So I'm trying to show various scenarios, right, how we work in the real world. I hope this would make sense to you. Okay, now we could have done it slightly differently also. Instead of using a for loop, we could have used a while loop also. Let me show you that. Same problem can be done in various styles. I'm just showing you all of those. Let's say I define I equal to 0, right, and sum equal to 0. So I will say while I less than length of this list. right? Length of this list. How much is the length? 1, 2, 3, 4, 5, 6. So while I less than 6, I am saying. So that I want to iterate over this entire list, right? One by one. So how many times this will run? This will start from here, then here, then here, then here, then here, then here. After that, it will break. So now I will say type type of orders amount orders amount right, orders amount of what? I. Initially I is 0, that means orders amount of 0 is 100. That means we are using indexing now, right? So initially it is 0, then 1, then 2. So we can get to know this value like that. So if type of this equal to int, right? Or type of, or I'll just take this, type of this equal to float. Same thing we are doing. Then what we want to do? Sum equal to sum plus, we can do this particular value, right? Else what we want to do? Else I equal to I plus 1, and we can continue. That means otherwise you please skip it. You please skip it, right? And see, if it will go to this part, it won't go to the else part. Then also we have to increase the value of I, right? Because otherwise it will become a infinite loop. So I will increase the value of I equal to I plus 1, right? I hope this is clear. Because what happens if, let's say, I do not give it here? You might be thinking why we are giving two times. If we do not give it here, it will directly go to continue, and then it will reach at the starting here without invoking this. Because if you do not increment the value of I, that will become an infinite loop. You do not want to do that. That's why you want to put this, right? And I can say print sum. If I run this should give me the same answer. I'm showing you various approaches. You can see all of them are pretty easy. Now I can do it in one more style. Three ways I am showing you. I have done using your for. I have shown using while. In while also I can show using one more way, which is I can say while true. While true. Right? While true. So what I will do, while true means infinite loop. Until we break, it will continue. So if type and all this equal to this, sum equal to this is fine. Else I equal to I plus 1 continue. This is to skip the none, invalid, all these things. And then what we have to do here? And then what we have to do? We are saying I equal to I plus 1. But we have to even, we are not checking the condition here. This will always come true. So we increase the value of I and say if our I equal to length of order amounts, then we need to break. Then we need to break. Right? So I wanted to show a use case where I use continue and break. Right? Break will break this loop. Break will break this loop. Continue will again bring you back to the next iteration of this loop. Right? So when you say break, the while loop will be terminated actually. Right? So I can do it the same way also. Continue, why we are using here? Just to skip these values, invalid, none, because when data types do not match, I want to skip these values. That's where I'm using continue. Break is when I feel, okay, I have iterated the entire list. Now I want to break, right? Break the loop. Then it's for that. Now I will do Control R and I'll show the result would be the same. So I hope we have understood this well. Okay, this should be fine. Now let me remove all of this. So you understood about loops also. I'll provide you the notes, do not worry. Now I will take this orders equal to this right? Now what I will do, I want to say that, okay, can you tell me where exactly on which index this is present? I can search for it, and this should, I want the index of it. How will I do? I'll say print orders dot index, because I want to get the index of what? Index of this customer ID I am providing. It should give me 2, right? So this is the index on which this particular number is present, right? I could even search for this, right? It should give me 1. Now, what if I give something which is not there? 1, 2, 3. What will happen? It gives me error is not in this list, right? Because since it has to return the index, it gives us an error saying it's not there in the list. Later, we will see in our exception handling, error handling, that how we can do it gracefully, because we do not want our code to break like this, right? It should have said, sorry, your number does not exist in this, right? It should not have given an error rightly. We will see later in our course. Okay. Now, let's say, can I do the same for your tuple? What do you think? Just think of it. Just think of it. 11599 should work, because we are not doing any manipulation here. We are not doing any change here, right? So definitely it should work. So it's a good enough idea for you to be that what functions would work for your list, what functions would work for your tuple, right? Okay. So now, is there any way that we want to find, let's say 1, 2, 3, we want to just check whether 1, 2, 3 is present in this or not. But if it is not present, it should not give us an error. It should just say it's present or not. That's it. Then you have a much safer way. You can say, 11599 in orders, right? If I print, this says true because it is present. But if I say 1, 2, 3, it will say false because it's not present. So this is graceful. This is graceful, right? But it does not give you the index, by the way. It just gives you limited information whether it's present or not. Okay, so we are good with this. Now, what if you, let's say, have a orders list, and you have some order IDs here: order ID 50, order ID 50, order ID 40, and let's say order ID 50 again, 30, and another order ID 50, right? Some order IDs are repeating. Now, what you want to find is, let's say you want to find the count of order ID 50 here, right? So let's say I will say print orders dot count 50. This should give me the count of this. So it is coming 4 times, right? Very, very straightforward. What if I give something which is not here? Should give 0. It's not available. 0 times. So this is how you can get the count of an element inside the list, right? Count of element inside the list. Now think of it whether it will be applicable for a tuple or not. I leave it to you, right? Mention in the comments whether it will be applicable for tuple or not. You just answer that in the comments. Okay. Now I can even do a sort of it. Sort, right? Now you might think, oh, we have sorted, it's giving none. Actually, what we have to do, we have to say orders dot sort, because it does not return anything that way. It does not return anything. It sorts the list in place. So if I print orders, it will print the sorted list. You can see the sorted list, right? I hope, because you understand that sort is not going to give us anything. It sorts it. That's it. So when you print orders dot sort, of course it will give you none. So you now print orders. It will give you the list. Now what if we want to reverse this list now? We say orders dot reverse. So it's more like a descending order now, isn't it? It's more like a descending order. Okay. Now you tell me, again mention whether this sort and reverse will it work for a tuple or not. Mention in the comments whether it will work for a tuple or not. You do not have to try it. You think logically and tell whether it will work or not. Okay. Now one more interesting thing I want to showcase. Let's say I have this orders and I am creating a new orders new equal to, and I assign the same thing. I assign the same thing. Now let's say if I make any change to the new list or old list, will it reflect to the other one? Right? Will it reflect to the other one? Let's say I am saying orders new, and I am, let's say, changing the value at the first index. First index is this one, right? And I am making it 200. The value I am making 200. Now I am saying print orders. I'm making the change in the new one, but I'm printing orders, and you would be surprised to see this is reflecting in the old also. Why? Because it's just two lists pointing to the same memory location. It's not actual copy. One memory location and two names pointing to it. Either you refer it with orders or orders. Two references. So if you make change in one, it will reflect to the other. But if you truly want to make a copy of it, right, then you have to use copy. You have to use copy. I'll just show you that. So I can say orders dot copy, right? And now if I make a change, it won't reflect in the old one. You can see this. Now these two are separate lists. So if you make change in one, it does not reflect to another because these are at two different memory locations. So you have to use dot copy in order to make an actual copy of it. Otherwise, both of them will point to the same list. Right? I hope this makes sense. Now, let's say I am having some customer IDs, and let's say I have 102, 105, 102. That means some of them are repeating. Let's say 103, 107, whatever coming to my mind, I am writing 109, 110, and 109. Let's say these are the customer IDs available. Now what I want to do is I want to find the list of unique customers. Find the list of unique customers. How do you find that? Let me create a new list because I want to create a new list, right? So I will create a list called as unique customers, and I will define as an empty list right now. I'll define as an empty list. Now what I will do for X in customer IDs, for X in customer IDs, what I want to do, right? So for X in customer IDs, I want to do if, that means I want to iterate over this entire thing. Now initially it will be 102 value. Now if x would be 102 in the first case, right? If X in, if it is available as a part of this list, if X in unique customers, then that means this value is added here. So continue. Do not worry, skip it. Because I want everything to come once only, right? Else, what I would say, unique customers, right? Unique customers dot append X. Now you think right now what will happen? Initially the value will be 102. So if 102 in unique customers, no, because the list itself is empty right now. So it will go to the else part. And what it will do, it will append 102 at the end. So this will become 102. Right? Next time what will happen? It will again have 105 as the value. It will again go to this part. It will append 105 here. Next time what will happen? It will have 102 here. So if X in unique customers, yes, it's there, 102, right? So what it will do, it will continue. That means it will go to the next value, 103. 103 not here, so 103 will come here. Like that, it will keep going. I hope you got it, right? And now let me just print this. Print. I can give a new line. Print unique customers. And I will print this. So you can see these are just unique. Duplicates are not coming now. Duplicates are coming just one time. It's not repeating. Right? Can be very, very handy things when you are working in production. I hope this makes sense. Now, we could have done it one other way, which is a very, very easy way without doing all of this. What we could have done is, let me remove all of this. Let me remove all of this. Set does not hold repeated values. If you put a value 5 times in a set, it will hold only one time. So, can we convert this to a set and things will be done? How to do? I can say set and then I can put pass on this customer IDs. That's it. I just wrap it around a set and this will convert my list to a set. And then I will say unique customers equal to. That's it. Nothing else. And if you print this unique customers, it will be truly unique, right? So that's the property of a set that it if you put the same value multiple times, it hold only once time. You cannot repeat it. So I just converted my repeated list to a set and it has taken care of the things. Right? Anyways, we will talk about set in our future sessions, but I hope this should give you an idea. So I think the session is getting long. I would hold on for the remaining things and we can have a part two for this because list and tuple is super super important. I really do not want to cover everything in one go. I want to give you time so that you can process the information, take it at your own pace. Now again, I would say this was my third session in the entire series, right? If you have not watched the other two sessions, do check. I'm trying my best to give you a very very quality content, the things which matters the most. That's why I'm coming up with orders file and a customers file to give you that thought process around it, right? So I would say if you have not subscribed to my channel, please do subscribe now. Do like this video, comment on how do you feel about it, and that would be a really motivating thing for me. So with this, I would end the session and I hope you truly liked it. Thanks a lot.